Haidi Xu, and here's my project for network science and applications. My topic is extensive evaluation of community detection algorithm using sites and hashtags. So when we talk about the community, it is a fundamental element in social media for communication and collaboration. Understanding community structure in social media is critical due to its broad applications such as friend recommendations, link predictions, and collaborative filtering. However, there is no widely accepted definition of community in literature. So, informally, I think a community is a densely connected group of nodes that is sparsely connected to the rest of the network. So, in the other words, a community should have more internal than external connections. I think that makes sense. And the community detection problem has been extensively studied. Various algorithms have been proposed to minimize or maximize the goodness measurement, such as modularity, eigenvector, and conductance, etc. In general, the community detection algorithms can be categorized into disjoint and overlapping algorithms. Comparing has been conducted to measure the performance of various community detection algorithms. Furthermore, the valid obtained communities with ground truth, which is the no community membership of users. Well, however, previous research in community detection algorithm design and evaluation has ignored an important metric, which is sense of the community. So I think the sense of community with strong ties in social media should be limited to 115 due to the cognitive constraint and time constraint of human being in both traditional social network and interest-based social network, like social media. So therefore, two large communities can contain weak connections. They are therefore not stable. In addition, two small communities don't have practical value. So in this paper, we use the term desirable community to refer to the community of sense in range 4 to 115. So don't ask me why it's 115. It's just experience, I think. So there are two famous methods here. I will introduction. Multi-level is a heuristic based algorithm based on modularity optimization. And multi-level first assign every node to a separate community, then select one node and checks the neighboring node attempting to group and the neighbor node with the selected node into a community if the grouping results in an increase in materiality. And the second one is the Newman's leading eigenvector. It works by moving the maximization process to the eigenspectrum to maximize modularity by using a matrix known as the modularity matrix. And the third one is the fast greedy. It's based upon modularity as well. It uses a greedy approach to optimize modularity in the category of overlapping algorithm. Click percolation method is most prominent, which measures two clicks into a community if they overlap more than a threshold. So this click augmentation algorithm is proposed in this paper, and when it gave a social network topology, and CAA algorithm discovered communities in the topology using the following steps. The first step fed an maximum clicks in the topology. And step 2, filter the overlapping clicks we sort the clicks based on their size, then use an overlapping threshold to control the amount of overlap between two clicks. The overlapping threshold is defined as percentage of overlapping nodes in the smaller click. So the next step, groups each click into a community by adding new nodes in one by one. Growing threshold is utilized for controlling the growth of each community. The growing threshold is defined as the ratio of the number of incoming eagles from the new node to other node in community over the size of the community. So here's the demo. Well, in the interest of time, I will briefly show one algorithm, which is the Neumann leading eigenvector. And because large-scale data will process a really long time, so I only use a small graph instead to demonstrate the example. So I will show the graph first. We can see it is not a big graph, but it is a small and indirect graph. And then if we run the Neumann eigenvector method, we can see it split into 5 modularity. So if we do the experiment for the data, and then we can get the results. Now here is the experiment result. We plot the community size distribution of communities obtained by the method I previously introduced. And this figure, due to the significant difference in the scale of the number of communities with different sizes, here is the community size distribution only from 1 to 15. And as discussed, the desirable community have size in the range of 4 to 115. So it is clear that both CAA and InfoMap have decent number of desirable community. Furthermore, and CAA products the largest numbers of the desirable communities. So here's the hashtag similarity. This figure shows the number of good communities based on user hashtag similarity. For eigenvector, there are less than 50 communities to choose from within a reasonable range. Therefore, we analyze all 20 communities in this range. In general, we found most of the algorithms are poor at detecting communities in which a theme exists. Okay, so more detail you can see in my paper, and thank you. That's all.